In today's video, we are going to learn how to simplify fractional exponents. So let's say you have 9 to the power 3 over 2. Now the best way to solve this is to separate the fraction, which is 3 over 2. So when we do that, we have 9 to the power 1 over 2, all raised to the third power. So what's the square root of 9? Root of 9 is equals to 3. So what to do now is to raise 3 to the power of 3. So 3 raised to the power of 3 is equals to 27. So our answer for 9 raised to the power 3 over 2 is equals to 27. So now that you have known that, let's take another example. Let's say you have 8 to the power 2 over 3. And again, we are going to split the fractions. Now we have 8 to the power 1 over 3, all raised to the second power. So 8 to the power 1 over 3 is like finding the cube roots of 8, which is a number that can multiply itself 3 times to give 8. The number is equals to 2, because 2 multiplied by 2 is equals to 8. So we have our 2 raised to the power of 2. So 2 raised to the power of 2 is simply equals to 4. So our answer for 8 raised to the power 2/3 is equals to 4. Now let's take another example. Let's say you have 16 raised to the power 5 over 4. Again, we're going to split the fractions. We have 16 to the power 1 over 4, all raised to the 5th power. So 16 to the power, that is the 4th root of 16, is equals to 2. So we have 2 raised to the power 5. 2 raised to the 5th power is equals to 32, which is 2 multiplied by 2, multiplied by 2, multiplied by 2, is equals to 32. Now let's take a different approach to our question. Let's say you have the cube root of 64 to the power 2. How do you solve this? You can pause this video and give it a try. Now, in order to solve this question, we are going to first of all rewrite it. So when we rewrite it, know that 3 is the index number. So 3 is going to be the denominator in the fraction. And then the exponent 2 is going to be the numerator. So we have 64 to the power 2 over 3. And just as we have done before, we are going to split the fractions. So we have 64 to the power 1 over 3, all raised to the second power. Now the cube root of 64 is equals to 4, because 4 multiplying itself 3 times is going to be 64. So we have 4 raised to the power 2. And 4 raised to the power 2 is equals to 16. So our answer here is equals to 16. Now let's take another similar example. This one is the 4th root of 81 to the power 3. Now, we are also going to write the question. Now, when we write it, we have 81 to the power 3 over 4. When we split the fractions, we have 81 raised to the power 1 over 4, all raised to the power 3. Now, 81 raised to the power 1 over 4 is equals to 3, because 3 multiplying itself 4 times is equals to 81. So we have 3 all raised to the power of 3, which is equals to 27. So our answer for the 4th root of 81 raised to the power of 3 is simply equals to 27. Now, another similar example goes like this. The 5th root of 32 to the power of 4. Now, rewriting it, we have 32 raised to the power 4 over 5. Again, splitting the fractions, we have 32 raised to the power 1 over 5, all raised to the power 4. And 32 raised to the power 1 over 5 is equals to 2, because 2 multiplying itself 5 times is equals to 32. So we have 2 raised to the power 4. So our answer here is simply equals to 16. So we have the 5th root of 32 raised to the power 4 to be equals to 16. Now, what if you have a negative exponent let's say, for example, you have 25 raised to the power negative 3 over 2. How do you solve this? In order to solve this question, we have to take 25 to the power 3 over 2 below. So we have 1 over 25 raised to the power 3 over 2. So as you can see, we have made 25 to the power 3 over 2 the denominator, just to get rid of the negative. So just as we have been solving before, we have to split the fractions. When we split the fractions, we have 1 over 25 raised to the power 1 over 2, all raised to the third power. So now the square root of 25 is equals to 5. So we have 1 over 5 all raised to the power of 3. And 5 raised to the power 3 is 5 raised to the third power is equals to 125. So answer is equals to 1 over 125. Now, let's take this example, not actually involving numbers, but you might see it in a couple of questions. Let's say you have the cube roots of x raised to the power of 4 multiplied by the fourth root of x raised to the power of 5. Now, this can be made very simple. Let's say if we have the same index number, we can just add x raised to the power of 4 and x raised to the power of 5. But in this case, we have different index numbers, which is 3 and 4. So we're just going to go ahead to write it just as we did before. So writing it, we have x to the power 4 over 3 multiplied by 5 to the power multiplied by x to the power 5 over 4. Now, in order to solve this question, we are going to use a particular law of indices. And it goes like this: x raised to the power of 2, for example, x raised to the power of 2 multiplied by x raised to the power of 4 is equals to x raised to the power of 6. It's simply saying when you have the same base, you can add the exponents, and in this case, 4 and 2 are the exponents. So back to our question, our exponents here are 3, 4 over 3, and 5 over 4. So adding them, we have 4 over 3 plus 5 over 4. So this is going to give us 31 over 12. So taking it back to the question, we have x raised to the power 31 over 12. Now writing it back to the other form, we have the 12th root of x raised to the power 31. Now you can further simplify this. I'd like to see answers in the comment section. Just try simplifying this further because it's possible. Alright, see you in my next video. Bye.